Hi, this is Tavi Greiner, Astronomy.fm's Vice President of Communications. If you enjoy our programming, please let us know with a donation to astronomy.fm/donate. We really do rely on your support, and it's true, every little bit counts.
AFM.
Program complete. Enter when ready.
The curtain of night is drawn back. The telescopes are trained. The domes are open. The audience is set. Now, step into the event horizon.
Good evening, everyone, and welcome to the Event Horizon here on Astronomy.fm radio. It is another Friday night, and what are we doing Friday nights, Nick?
We're taking over the world! God's alive, I tell you!
We do. This is February the 8th, 2019, about 9 o'clock in the evening for those of us in the eastern portion of North America. Universal Time puts it Saturday morning, 2 o'clock in the morning on February the 9th. And that means we're live for the next hour, and that also means we have our chat room open for you to come on over, say hi, ask us questions. We're more than happy to have as many people as we can hold in our chat room. Let's break the record. How many have we had maximum before? We've had probably...
in the past, we've had larger chat rooms.
Mm-hmm.
But in our chat room tonight, there's me, there's you, Marty, there's Cassie, Glenn, StarStorm, Black Projects, Red Shirt 3. Welcome back, my friend. We've missed you.
It's easy to get here. Go to the homepage, astronomy.fm. Look near the bottom. You'll see where it says chat. Just click on that. You get a login page. Just type in a name. Erase anything that's in the password. Leave it blank. Hit login, and you'll be in our chat room. Just try it to see what happens. If your computer explodes, well, it's not our fault. It was just a coincidence.
Actually, Marty, what I did about a couple of hours before the show, I went to the AFM Facebook page, and I put the link to click on to listen to us. Okay. And by the way, if just to let you know, folks, Saturday afternoon I will have the show posted as a YouTube video, and that will be on the AFM page. It will be on my page. It will be on the Under British Skies page, I guess, and I will be putting it out on Twitter.
So it'll be linked onto our Facebook page?
Yep.
Cool.
I always put the shows that I have there, and if our other producer, who's a lovely chap I know, would just give me the links to the Space Pirates, I'd put the Pirates up too.
We'll get there. We got extra work to do. Hey, anybody want to volunteer out there to help do some work on Astronomy.fm?
Yeah, what it is, we need more Sky Guides. More Sky Guides mean more shows, more live shows, and recorded shows, which are actually under our own banner. We also need radio show producers.
So anybody that's experienced in that would prefer to already experienced in that field, by the way.
No, I'm not going to do that, StarStorm. Don't worry. What I was going to say was Michael and Rob really do put a lot of work in. They're here for us on Wednesdays and Fridays. And even those guys need a break. We need people who are willing to pick up and help out, lend a hand. Because that way, if Rob or Michael can't be available and you're one of our show producers, you can be here. You can have us on the air. You can make sure the show gets put into the slots to be playing the next day over the next 24 hours. And of course, that way we have more live shows. And
you also need to know sound editing too.
Yeah, that would help. But as I say,
that's a must.
Oh yes, but the thing is, the more people we have who will volunteer to help out, the more we can do live shows. And I'll be honest with you, I wish if I was doing the sound side of it, what do Sky Guides do? Basically, the Sky Guides are the people who are on the radio shows that we produce as our own banner.
We're known as the talent in the industry.
Yeah, we are talented. We are talented, Marty.
I didn't say that. I didn't say we're talented. I said we're known as the talent in the business.
Yeah, but anyway, So the Sky Guides are like me and Marty. We're the people who's on the live shows or on the recorded shows under the AFM banner. So other Sky Guides are is Mary McIntyre and Neil Norman. And of course, previously we've had Paul Harper and the rest of the Under British Skies crew. We are all Sky Guides.
We have the York crew.
We have the York crew. They are they are Sky Guides because
they are Sky Guides. Yes,
they do live shows on astronomy.fm, as well as the fact that their shows also go out on over the York University site as well. So if you are on the air like me and Marty are right now, or Marty and I, take your pick, you are a Sky Guide. Yes, we do guide you through the sky, Glenn. We tell you about all the exciting news. We talk about constellations. We talk about planets.
Well, you could call us the Universe Guides.
Yeah, that would be interesting.
Almost like Hitchhiker's Guides to the Universe.
We're not quite as good as the book.
Not quite as good that way, no.
The book knows everything, including 42, the meaning of life, the universe. That's right. And everything, and why many black holes can't devour the Earth.
And whatever we don't know, we just make it up.
Well, as I said, we're not pan-dimensional beings masquerading as mice.
That's true.
You and me and a dog named Blue, Glenn? Is it a blue tick coonhound or something?
And what's an improbability drive, right?
Oh, that's the Heart of Gold, and that was nicked by Zaphod Beeblebrox.
Yep, that was it. Yep.
And it caused whales to appear in space and explode. Bowls of petunias, and of course the dolphins were the first to actually get out of there and say thank you for the fish. We're gone, goodbye, because they knew about the oncoming demolition of the Earth. Are you serious? That is actually the space station that Brewster Rocket works on.
There you go.
See, I'm watching what you're saying, Glenn. Come up and play. We have fun on the shows. I think the thing about being a Sky Guide is you get to have fun. Even the York, I've listened to York University. They have lots of good fun when they're doing their shows. We have fun here. I know that Marty and Diane have a lot of fun on their show. I do listen.
No, we're dead serious all the time. No joking around in that show ever.
Yeah, right. Arr. But no, seriously, if you're basically the idea of being a Sky Guide is that you're on the air, either live or recorded. You're under the AFM banner, and you get to have a lot of good fun. And let's face it, if it wasn't fun, we wouldn't do it. I'm not quite Captain America, Glenn. More like Tony Stark, I think, really, in ego. Yeah, I don't know if anybody heard that comment, but StarStorm's comment at time was, just be grateful you don't have a mild-mannered Bruce Banner in the house.
There you go. All right, what's up in the sky? Where or what? Where do we want to start out with?
Let's start with the center of the solar system. I want to thank Black Projects for this.
That would be me.
Well, I'm going to go first for a change, Marty.
I'm saying you said center of the solar system, so my center of the solar system is me. See, that's how it works.
Yeah.
There you go.
Okay, thanks to Black Projects. He actually told me about this about an hour ago, roughly. As he comments, so it begins. The Earth is actually entering a solar wind stream from a coronal hole. The substorm from earlier was the first of a few to come over tonight and for the next few nights. The Icelanders have got a G2K6 solar storm going on. Now, I happen to know the fact that they've also got some pretty bad weather as well, so which is kind of sad for them. But if you're in clear skies and you're in northern climes, you should get a good chance for some very, very good aurora.
You should. They've been happening kind of regularly too. So there's been like a regular coronal hole that's been on the sun, and every time it goes around, it kicks into that, and other stuff's been
kind of like a lighthouse.
So yeah, kind of like that. But it's been like every other week or so, we get a little bit of
but it could pick up again.
Yeah. Get a little
The
surge.
thing that gets me is everybody's going, "Oh, this is solar minimum." We have our star, our G3 yellow dwarf. It's a bit more orangey than yellow. Is actually a variable star, which means it gets to do things like, they're getting complacent on the planet Earth, so I'm just going to send them a nice reminder that I am very close by, and so it does. The solar wind, and of course CMEs, coronal holes, they all happen. And interestingly, considering it's supposed to be a very deep solar minimum at the moment, the sun is much more active than most people realize.
Mm-hmm.
Not as active as it has been about 10, 15 odd years ago when it was tossing off quite a few X-class flares. Nothing as that dangerous to the planet, but it certainly puts satellites at risk when the sun is at solar maximum. And to be honest, I've noticed that over the last few cycles, it's not really been a proper maximum. It seems to have been stronger than the minimum, but not as strong as it could be, which has prompted a lot of people to think, are we going towards a Maunder minimum? That I can't confirm or not, because the simple fact is, if it is a Maunder minimum, then we are looking at possibly a wee ice age happening. During the last one that was actually recorded, the Thames froze deep enough that they could light a fire and roast oxes in the middle of the river. So you are talking about a good 10, 15 feet of ice.
Mm-hmm.
But it hasn't been that bad. Obviously, global warming and climate change, which exists as much as it's inconvenient for certain people, is offsetting, I think, the Maunder minimum. Now, the 300-year cycle was already passed in the 70s. Yep, that's a good point. But as I say, it is really a case of, you can't say that the sun is boring and it's in a minimum, because I just think that being a variable star, it can throw off hisses every now and again and just prove how wrong we are.
Depends on where you live and how good of equipment you have.
This is true. So all those people who were moaning about, I just bought the latest solar telescope for my backyard, are probably not all that badly upset.
Well, if it's a hydrogen alpha filtered telescope, you're always getting promises almost all throughout all the minimums. There's usually at least a little bit of promise activity on the sun.
Now, Black Projects has put a link in saying this was Iceland around 10 p.m. UTC. So let's have a quick look at this, shall we, Marty? Yes, Glenn, it is a variable star.
So minimally, but it is.
So that's quite a nice little display there. If you look at the picture, Black Projects has shared with us.
Okay.
So I wouldn't have with that. I'd be quite happy with that, considering it's supposed to be solar minimum.
Mm-hmm. Been a while since I've seen any aurora. Well, one thing that's good, though, one thing helpful for Northern Hemisphere aurora watchers is that wintertime we get the most nighttime. Yeah. As opposed to the southern polar regions, it's like they get some aurora when it's not 24 hours of sunlight.
So now, Black Projects has commented it's a G2 variable. So I'm just bear me for 1 second whilst I pull up a link about that.
The G is the designation in its spectral type. OBAFG, is it MNO? I think the order, and then
if you've got an O-type star,
then 1 through 10 in between. Yeah, spectral class.
Yeah, if you have an O-type star, you have my total.
Oh wait,
sympathy.
O is the bright one. MN is a difference. OBAFG KMN. That's the order, and they've changed those around a little bit too.
So basically, what you're seeing, a G-type is a main sequence dwarf star. Okay. So it will fuse hydrogen for approximately 10 billion years until it's exhausted at the center of the star. When this happens, it expands many times and becomes a red giant, such as Aldebaran or Alpha Tauri. And then eventually the red giant sheds its outer layers of gas and it creates a planetary nebula. The core rapidly cools and contracts into a compact, dense white dwarf. Please note, they do not go supernova. A lot of people get really, really hipped on that, and as far as I'm concerned, a white dwarf, I don't think it has that potential.
Oh, wait, a white dwarf going supernova?
Yeah.
It can.
It can?
It can.
Okay.
Yes.
Go for it, Marty.
That becomes a type 2 or type 1A supernova. Basically, when it's in a binary system.
Yeah.
A white dwarf can go supernova. No, but a white dwarf can go supernova.
As StarStorm points out, this is not Tatooine. No matter how much a certain shield agent will probably wish you was.
Binary. Thanks, Mark. Type 1A will be a binary supernova. Got it.
So I can say it has to be a binary star to become a type 1 supernova.
Mm-hmm.
And just 1 second, and I'll just pull up a link for that. Well,
right.
Here we go. That was pretty easy. You've got to love Google, haven't you? So a type 1 supernova is a type of supernova which occurs in binary systems. One of the stars has to be a white dwarf. The other one can be anything from a giant star to an even smaller white dwarf. Physically, carbon mass white dwarfs with a low rotation rate are limited to about 1.44 to below 1.4 solar masses. Okay, so I'll just put that link into there.
Okay.
Oh, we're having good fun tonight, aren't we?
We are. I've got another sun article before we leave the sun.
Yep, go for it.
Ready for it? All right, let me put it into our chat room here. This is, where is our chat room? There it is. All right, here it comes. Copy and paste. Oh, the sun. Always been that mystery of how things are happening on the sun, obviously. And there's a new article here about scientists show sun's magnetic waves behave differently than believed, because what they're thinking is that the magnetic waves above the photosphere of the sun are being affected by acoustic waves and inside the sun. So remember that always people forget, wow, what's charging up the corona of the sun? Thinking, well, maybe it's, somebody said, maybe it's sound waves. And everybody, no, it couldn't be sound waves. Maybe it's sound waves. Maybe it couldn't be sound waves. Well, maybe it's magnetic fields. Well, it could be magnetic fields. I don't know. We can't tell. Well, now they think it's kind of a combination of both. That acoustic waves in the sun actually affect the magnetic waves above the photosphere of the sun. So I thought, oh, that's pretty interesting. So stuff wiggles around and on the surface, and it affects the magnetic fields above it. Go ahead.
Okay, so since we seem to be talking about the sun for a bit, here's another sun story for you. No, okay. Not the sun, as in the daily newspaper.
Okay.
Okay, so scientists reveal fine-grained structure in the outer corona of the sun. So what's happening is back in 1610, Galileo redesigned the telescope and discovered Jupiter's 4 moons. 400 years later, the Hubble Space Telescope is using its powerful optics to look into deep space, enabling scientists to pin down the age of the universe. Fine. Now, suffice to say, it's getting a better look at things, and which produces major scientific advances. On a paper published in July in the Astrophysical Journal, a team of scientists led by Craig DeForest Kelly, a solar physicist at Southwest Research Institute's branch in Boulder, Colorado, demonstrated that this historical trend still holds. Using advanced algorithms and data cleaning techniques, they've discovered never before detected fine-grained structures in the outer corona. Now, that's the sun's million-degree atmosphere. Mm-hmm. By analyzing the images taken by stereo, the new results also provide foreshadowing of what might be seen by the Parker Sun Probe, which was launched around summer 2018, and it's actually going to orbit directly through that region. So the outer corona is obviously the source of the solar wind, the stream of charged particles which flows outward from the sun in all directions. Measured near the Earth, the magnetic fields embedded within the solar wind are intertwined and complex. What causes this remains unclear, but in deep space, the solar wind is turbulent and gusty. Well, there's a nice meteorological term for you.
Mm-hmm.
How did it get that way? Well, did it leave the sun smooth and become turbulent as it crosses the solar system, or are the gusts telling us about the sun itself? So in order to find out about this, we need to observe the outer corona, which is the source of the solar wind, in detail. Now, if the sun itself is causing the turbulence, then we'll be able to see complex structures right from the beginning of the wind's journey. But the existing data didn't show that. Well, not at least until now. So, previous images of the corona showed the region as a smooth laminar structure, according to Nikki Weil, a solar physicist at Goddard Space Flight Center in Greenbelt, Maryland, and co-author of the studies. It turns out that the apparent smoothness was actually due to limitations in our image resolution. So what they've done, they started looking at coronagraph images, pictures of the sun's atmosphere, produced by a telescope that blocks out the light from the much brighter surface. And there is actually a video on how to read a NASA stereo image. Now, the interesting thing, this is also another place to go and find comets. Believe it or not, because a lot of comets... Yeah, back to comets. What can I say? I'm a comet guy.
That's all right.
Yes, they are like cats, StarStorm. They have tails and they do with them as they wish. Gotta love David Levy. Anyway, so back to the sun. What happens is, now that we're actually improving our imaging capabilities and our analytic abilities, we're seeing that this may not actually be the smooth laminar flow that we've come to expect. So they're now trying to get longer, not only longer exposures, they want them to be higher resolutions. It's kind of limited at the moment. The instruments that are in space, unlike Galileo, they couldn't tinker with the hardware itself. So instead they took a software approach, squeezing out the highest possible data quality by improving the Core 2 signal to noise ratio. Now, what it is, the images are actually generated by the Core 2 coronagraph aboard NASA's Stereo A spacecraft. This circles the sun between the Earth and Venus. So by improving the signal to noise ratio, it's kind of like having an FM radio. The more time you take and effort you put into tuning the signal, the better you hear. And this is kind of it's very similar. I'm not going to say exactly the same because it isn't, but the signal to noise ratio is an important concept in all scientific disciplines. It measures how well you can distinguish between the thing you care about, which is measuring the signal, from the things you don't, the noise. So what's happening now is, say, for instance, you have great hearing. You notice the tiniest of mouse squeaks late at night. You can eavesdrop on the whispers of your kids, huddled about 20 feet away, or a bunch of school kids. So that is when the noise is low. But it's a different ballgame when you're standing in the front row of, say, Queen live at Wembley or something. You're right in the front. Boom.
I was going to say, or on Ohio State halftime show.
Yeah. So basically the actual environment and the sounds are just too overpowering. No matter how carefully you listen, you can't hear the mouse squeaks and the whispers, because it can't cut through all the noise, which is from being that close to the music. The problem isn't your hearing, it's the poor signal to noise ratio. So think about the Core 2's... Yeah. So think about the coronagraphs like being your hearing. The instrument is sensitive enough to image the corona in great detail, but its measurements are polluted by noise from space, from even the wiring of the instrument. So what they're doing, they're identifying and separating out that noise to boost the signal to noise ratio and revealing the outer corona in more detail. So the team estimates noise reduction now at about a factor of 2.4 for each image, a factor of 10 when combining them over a 20-minute period. But the rest of this is up to sophisticated computer programs, algorithms, designed and tested to extract out the true corona from the background hash.
I've got a little bit of recording of that. You want to hear it?
Sure.
Let's listen to this. It's a Sun song called My Corona. That was the data they filtered out so they could hear that.
Yeah. Well, so what Glenn is saying is you may hear what you want to hear, and you discard the rest. That is a very good comparison, Glenn. So that is one way to think about it. So what they're doing now, they're now actually being able to filter out the stuff they don't need and just keeping what they want to see and hear. And so now they can see better. And Glenn says you're showing your age, Marty.
No, I'm much older than that.
I could show my age too. I remember Duran Duran and all that stuff. God, 1980. Oh, actually, no, tell a lie. I can actually remember back to the Beatles. Go on.
You're looking at the girl who listens to Andrews Sisters on YouTube, okay?
The Andrews Sisters.
Yeah.
A little bit
anyway.
of reincarnation going on there, I think.
Oh, quite possibly.
Mm-hmm.
I slept was with Thor and Loki afterwards. And maybe Coulson too, eh, Mariah? Tatooine. Okay, and Glenn says he recalls the lads on the Ed Sullivan show. Yeah.
All right, let's see what else. We got a couple minutes to the half-hour point. All right, how about this? Since we're not quite the sun, let's talk about. Let me put this article in here. Remember this? Okay, go way back. Remember the supernova of 1987?
Yep.
Okay, a little bit update on that one. We put the article in their chat room here. There you go. 1987 in the southern hemisphere, in fact, I think it was the Large Magellanic Cloud. There was a supernova explosion, the first one seen this close to the Earth in about 400 years. Unfortunately, not visible from the northern hemisphere, just the southern hemisphere, as it was in the Large Magellanic Cloud. And they're still seeing the remnants of that supernova explosion. Now, the original idea was that as the star gets older and turns into a red giant star, and it expands tremendously, like to the orbit of Mars or Jupiter or so, if it was in this solar system, for instance, that the outer regions are so far out away from the core that the material starts actually floating away from the rest of the star. So it loses a lot of gas and material and stuff like that. But it doesn't lose it all. It retains a lot of it. And then what's left over is fusing hydrogen into helium into heavier elements until that crunches down together and explodes in a supernova explosion where the rest of the outer parts of the star explode. That light and those particles end up crashing into the particles that came off earlier in the star, crashing into it at about 6,000 miles an hour. Now, the idea was that stuff would be obliterated. Anything caught in like a planetary orbit around a star would be just obliterated in a supernova explosion, including the dust that was traveling out through space. Well, now they've actually found there's still dust around, left over after that explosion, which they thought should have been obliterated. So we got a couple ideas of what could be happening. Obviously, maybe the dust survived. Maybe the atoms that were part of the gas actually combined together to make more dust, brand new dust. But they've definitely found more dust than what should be left, should have been destroyed. So the latest discovery on supernova 1987.
See, basically, once it gets down, once the star is producing iron, it's dead.
Mm-hmm.
Because there isn't sufficient energy available to fuse the iron into anything else. So a star remains on unless it explodes. Because basically what's going to happen is gravity and the outward radiation pressure tend to be in balance.
Mm-hmm.
As the star stops burning hydrogen and the fusion stops, it shuts off the outward radiation pressure. After
it stops fusing hydrogen into helium.
Yeah. So basically, when that starts to happen, the equilibrium, there's a big word for you, equilibrium of the star is disrupted. Equilibrium, thank you. It's been a long day. But as I say, once the equilibrium is disrupted, the star will collapse and then it will expand. Whoops.
Mm-hmm.
That was my elbow against the printer.
The first collapse is kind of gentle.
The collapse is kind of gentle, but as I say, what happens afterwards isn't.
Yes.
And you get a beautiful planetary nebula.
Mm-hmm. And like I said, this article is surprisingly, the dust did not get destroyed by the supernova explosion. There's more there than what has been expected.
Now, Glenn is asking, can iron be compressed into a black hole?
Yes.
No, I mean, black holes you have to have a really super dense thing like a neutron star. When you get two neutron stars collide, then you can get a black hole.
Well, yeah.
I don't think the iron can be compressed into a black hole.
Depends on how much stuff is on top of it.
Okay, Redshirt 3 is back in chat. Redshirt 3. I don't believe that when a star's producing iron, it can collapse into a black hole, because I think at that point,
if there's more than 1.4 solar masses of material, what you can have is normal fusion of iron into heavier elements in normal fusion process in a star. That process stops, and that's generally in a smaller star. So if you have more than 1.4 solar masses that's not fusing, and there's more than that amount of mass, it will crush down that iron into either a neutron star or a black hole.
Yeah. Well, okay. The thing is, though, higher mass stars will switch from helium to carbon and extend their life. However, once iron is reached, fusion is halted, because iron is so tightly bound that no energy can be extracted by fusion.
Correct.
So
normal fusion
stops.
Under normal fusion, yes, the fusion process stops at iron.
Okay. Now, the other thing we have to take into consideration, due to atomic structure limits, all white dwarfs must less than the Chandrasekhar limit. If the mass is more, then they must lose their envelopes during their planetary nebula phase till they are below this mass. So a good example in the night sky would be the Cat's Eye Nebula. Okay, I'm going to put a link into here that I found whilst I was... fusion stops at iron because it's the most... Yeah. Okay, so end of a star's life. For stars less than 25 solar masses, their life is to evolve into white dwarfs after substantial mass loss. Once the star leaves the AGB, a symptomatic giant branch, it becomes a white dwarf. It depends on how fast it runs out of fuel. Higher mass stars will switch from helium to carbon and extend their lives. Even higher mass stars will burn neon after the carbon is used up. However, once iron is reached, fusion is halted because it is so tightly bound that energy can be extracted. Iron can fuse, but it absorbs energy in the process and the core temperature drops. So after evolving to a white dwarf, stars with original masses less than 25 solar masses slowly cool to become black dwarfs and suffer heat death. Greater than 25 masses, they undergo a more violent end to their lives. Carbon core can last for 600 years, neon burning for 1 year, oxygen for 6 months. This is very fast on the astronomical timescale. At 3 billion degrees, the core can fuse silicon into iron, and the entire core supply is used up in about a day. So heavier elements can be formed in supernovae, but to become a black hole, you need to create a situation where there is this huge gravitational
more mass
in that area. Yeah, yes. Mass. So after 1 day of silicon fusion, you become an inert iron core. And there's some pictures of the Whirlpool Galaxy there as well. One such supernova is 1991T in M51. So, supernova explosion, an inert iron core stops producing energy but continues to produce neutrinos, which release energy. Densities climb, protons and electrons combine to produce neutrons and more neutrinos. Sudden loss of energy causes the core collapse from lack of pressure support. Regions around the core are unsupported and plunge into the core of up to speeds of up 15% the speed of light. Neutron densities are now so high in the core that it is incompressible and rigid. Infalling layers strike the core and rebound. In a fraction of a second, a wave of matter forms a shock front, moves outward towards the stellar surface. This shock wave hits the surface of the star, explodes inward. Now this is probably what's going to answer Glenn's question. Inward shock compresses remaining stellar core into a neutron star or a black hole.
Mm-hmm.
So, as I say, with the loss of pressure from the core, the unsupported regions plunge inwards at about 100,000 kilometers a second. The material crashes into the rigid core. Tremendous temperatures and pressures build up. The layers bounce upward. A shockwave happens. It accelerates and within a few hours explodes on the surface of the star, rushing outward at thousands of kilometers a second. To be honest, it happens so fast you can only follow it using supercomputer simulations. Maps of density and flow show the details in regions where observations cannot be made. And of course, guess what this brings us to? SN 1987A, the first one discovered. It was visible to the naked eye. It was maximum brightest 85 days after detonation. With the slow decline over the next 2 years, there is actually, I see the link, thank you. And there's links from Black projects about hypernovas, and there's a constellations guide to February. Anyway, it goes in. The article goes into everything: neutrinos, gravity waves, Cherkanov radiation.
You're basically speaking Greek to me now.
Absolutely, and Russian.
Did you call it Chekhov radiation? That's the stuff that was invented.
Radiation.
That was invented in Russia. Yeah.
Cherenkov radiation.
Okay.
Because what happens is when the neutrinos are weakly interacting, our best neutrino telescopes are large tanks of water buried deep underground, like the one in Japan. Water contains a lot of protons in the form of hydrogen. Neutrinos from supernova travel at or near the speed of light. A lot of energy. On the rare occasion a neutrino hits a proton in the water tank, the collision will produce a positron, which recoils at such high speed that it emits a brief flash of light known as Cherenkov radiation, Cerenkof. And the detector is buried deeply in the Earth to eliminate cosmic rays. Otherwise, it would distort the detection of neutrinos. Only neutrinos can reach such depths. Then there's a block diagram of a neutrino detector.
All right. And on that note, we never did do our halfway station identification, did we?
No, we didn't, Marty.
Okay, I guess we'll do it. You're listening to the Event Horizon here on Astronomy.fm radio. It is Wednesday evening. This one is February the 8th, 2019. Approximately halfway through our hour of program for this evening. So that puts it about 9:30-ish for us here, the eastern portion of North America, and that would make it 2:30-ish in the morning, Saturday morning, February the 9th, 2019. Halfway through our program, so stick around. Come on over. Still got plenty of time to join us for the second half of the show. Come on over to our chat room if you like to. And we got some more programming coming up after the Event Horizon, including a new talking space, by the way.
And I could go on and on about gravity waves and everything. I will say two things for very possible brilliant events: Eta Carina and Betelgeuse. When they go, we are going to know about it. We will. I think we will see the result in daylight, if it doesn't create a very faint light for you to be able to read your newspaper by. And I don't mean on your Kindle. Okay, I'm getting tagged that we have the constellations for February. Let's get this done. Okay, February. Monoceros, yes, I saw that one. Okay, so the constellations of February. Auriga the Charioteer, Campopelagus the Giraffe, Canis Major, which tends to stay with us pretty much year-round, Columbia the Dove, Gemini the Twins, Lepus the Rabbit, Monoceros the Unicorn, I know why that was put in there, and Pictor the Painter's Easel. Now, this brings me, I guess this is my other hobby horse. If you're going to go looking for supernovae, if you're going to go looking for comets, you need to know how to star hop. You need to go from one constellation to another. You need to learn yourself around the sky, because that way, once you know once you have a good idea what's in every constellation, you can do what Charles Messier had to do the hard way. And I know a lot of people say, well, he didn't do too badly because he gave us a very nice, fun event twice a year, the Messier Marathon. To be honest, I actually find it I've done it once. That's it. Fine, it's done. It's over. I'm bored. I'm sorry, Marty. It is. Once you've done it the once, doing a Messier Marathon every year is boring.
Yeah, that's true. After you've done it once. Well, unless you find a better location, like high in a Hawaiian mountaintop.
Now, Red Shirts 3 says Eta Carina has occasional outbursts that are visible. This is probably one of the things. It's probably one of the most watched constellations in the southern hemisphere. And Betelgeuse would be like a second sun in the daylight sky. It will be fun, particularly if we get a very violent outburst from Eta Carina. I can guarantee that people will be getting themselves on flights to Australia, to New Zealand, to Chile, just to be able to say they've actually stood under the light of Eta Carina. Mm-hmm. Messier Marathons are madness. Yeah, it's total insanity just trying to keep up and stay awake to do it. I know people that have done it, and like they've complained that they've actually slept for 2 days afterwards.
Yeah,
and that's using telescopes all around the world. I don't want to know what the heck their bill was for logging into a remote telescope first in the northern hemisphere to start the marathon, and then going south, because they must have put quite a lot of money down to pay for the telescope and imaging time. When you consider it's the average deep sky object takes in most cases between 5 and 10 minutes to image for a color image. And there's something like 100 odd Messier objects. I'd rather do the Caldwell catalogue. It's much more fun. Mm-hmm. It's not as big, but Patrick Moore selected more interesting objects in my book. Okay, so now I've mentioned it, I suppose I better put a link into that. So
I've done part of the Herschel list too. That was listed for the Astronomical League, by the way.
You can actually, the Astronomical League has them. The Royal Astronomical Society of Canada has a list for these. Mm-hmm.
So I've seen all the Messier objects, and I've seen over 400 Herschel objects.
Yeah.
So far.
Okay. Here's. Okay. Now.
What you got?
Didn't like that link.
All right. You keep going. I'm going to do the moon and planets for the upcoming week or so. Right around February 9th and 10th, the moon will be just south of Mars. Well, several degrees south of Mars, but south of Mars and the planet Uranus. On the 13th, the moon will be in the constellation of the Hyades, but it's getting kind of full, so it'll be a little bit of a challenge. Well, where's that crescent? I can't remember. Well, it'll be in the Hyades on the 13th or so. On the 14th, Mars and Uranus are really close to each other, so start watching them now, and you'll see that they're actually pretty close to each other. February the 17th, the moon will be a half a degree south of the Beehive. And that's the one that's almost full. So it'll be a challenge, but if you get your scope out on the 17th, and you'll see it just south of the Beehive star cluster, and that's all coming up this week.
Okay, so the Caldwell catalogue link is in the chat room, and there's a nice little star chart. It is 109 objects. Patrick Moore created it as a complement to the Messier catalogue.
But more south.
Pardon?
But more south, I believe, right?
It's actually fairly well distributed across the sky. So the Caldwell catalogue is ordered by declination, with C1 being the most northerly and C109 the most southerly. Although NGC 42, 44, and the Hyades are listed out of sequence. But as I say, so what do we have here? We have 1 dark nebulae, 35 galaxies, 18 globular clusters, 9 nebulae, 25 star clusters, 6 star clusters and nebulae, 13 planetary nebulae, 2 supernova remnants, total 109. So you have first one is C1, it's NGC 188, it's an open cluster in Cephas, followed by the bow tie, and then there's a barred spiral in Draco. The Iris Nebula, Cat's Eye Nebula's there. There's a spiral galaxy in Camelopardalis.
The reason for this list was put together because Patrick Moore, like a lot of people, thought that there's a lot of objects that should be on the Messier list but weren't, because they're obviously bright as or brighter than a lot of the Messier objects. So he created his own catalog of another 100 objects. I think it was named after his mother's maiden name. Is that correct? No.
It's actually it's named after his other name, his other surname.
Oh, I thought it was somebody's maiden name.
Well, see, the thing is, his name is Patrick Caldwell Moore.
Okay. And
since the initial of Moore is M, and it's used for the Messier catalogs.
Yep.
So he used C, which is his last name, to name the list. And as I say, it is quite a nice little list.
Mm-hmm.
Like I say, it gives you've got a very nice star map there. And of course, let me just pop this up. And this is actually a image of all the. Just 1 second, because I'm having.
Alrighty.
There we go. There is the actual JPEG showing all the Caldwell catalogue images. And there's lots of my favourites in there. The Whale Galaxy. There's lots of my favourite Messier objects. Oh, you were okay. Thank you, Black Projects. I didn't see that. Me bad.
Yeah, if anybody's done any Messier observing, you definitely have come across other objects that should be part of the list, but somehow they just did not get there.
Well, there's the North America Nebula.
Mm-hmm. That's a pretty tough one, but it is visible.
Yeah,
sort
Crest
of.
Nebula,
Barely.
Flaming Star, East and West Veil Nebulas, Needle Galaxy, Eskimo or Clown Nebula, depending on how you want to call it. Hubble's Variable Nebula is there in Monoceros. The Rosette Nebula. Spindle Galaxy, the Saturn Nebula, Bernard's Galaxy, the Ghost of Jupiter, the Antennae Galaxies, the Helix is there, Sculptor Galaxy, the Bug Nebula. There's the RCRA Nebula, which is in Corona Australis. So obviously we're beginning to head south. NGC 300, which is a beautiful galaxy to look at. The 8 Burst Nebula. My favorite is C77, Centralis A. It's often called the Hamburger Galaxy. And of course, Omega Centauri is there.
Yeah, you definitely have to be. Well, we'd have to be definitely in the southern hemisphere to see those easily.
Well, you'd have to use something like our telescope.
Yeah. Well, or just travel south.
Yeah, you could do.
Some of those are big and bright.
See, there is a postscript here. C89 was mistakenly written as NGC 6067 in the original, but the description is of NGC 6087.
Mm-hmm.
So you can get two. You got
just like the Messier catalog had some discrepancies in it that.
Oh yes, absolutely.
People had to figure out, and they're not quite sure of all of them, anyways.
Well, no, some of them weren't done by him. Some were done by his sister and by his assistant,
and other astronomers that sent him information and observations.
And why was the Messier catalogue done? Because he was a comet hunter.
Which
and
is
he decided,
which is the popular thing to do back in the day.
well, yes, it was. And of course, the thing was, by cataloging all the nebulae, etc., he could eliminate them from his hunt for comets.
So the way you do comet hunting is get your big a telescope you can, and well, most people prefer to start like right after the sun sets and scan the western sky, and then before sunrise, scan the eastern sky. What you're looking for is little fuzzy things that was what comets look like when they're first sighted. Just fuzzy little patches in the sky, not resolvable into a star. And as Messier discovered, there's fuzzy spots that are not comets. In fact, what you have to do is you have to go back and observe the same fuzzy spot over and over and see if it's moved. If it's moved, it's a comet. If it hasn't moved, it's a permanent fuzzy spot, not a comet.
But as I say, it is I may actually decide at some point to do the full Caldwell catalog. I have our telescope. I've got an awful lot of points sitting on my account at the moment. So sounds like a fun thing for me to do, and I'll put up an album on Facebook.
Yeah, you don't need a one of the big telescopes either. You can use one of the smaller ones.
Yeah, but I got if you're socked in with weather.
Yes. All right. There's a new, completely different topic from the JAXA Space Agency, the Hayabusa mission to Ryugu. What's the name of that? Ryugu? No, it's
Ryugu.
Ryugu
is probably close enough. We're going to get.
Yes, Ryugu.
Ryugu.
That's as close as we can pronounce it here, or at least best I can pronounce it. Well, anyways, obviously they've got the Hayabusa mission there, and they're seeing features on that object, and they're actually starting to officially name those objects. So there's a whole article on the naming process, and it's actually a Japanese story that the names have been based on. A little bit of discrepancy because there's I think a crater on Venus that was named after one of the characters in the story, so it was not going to be allowed, and then I think they kind of modified it a little bit, so they actually allowed the same character name on Ryugu.
Yeah,
so it's an interesting article to read the whole thing, and it's got maps of where the locations or the features are on this asteroid. So check it out.
So what it is, one of the names for the Minerva 1 and Mascot landing sites, one is Alice's Wonderland, and the other is Trinitas. And okay, they're not officially recognized by the IAU.
Right.
If I was voted onto the IAU, I would move to recognize them because I think it's nice. I like that. But yes, a lot of these places.
They first had nicknames that they did unofficially, so they could talk the same to each other, during the mission.
Yeah. But you know what? This is JAXA's mission. I think that they really should be allowed to name some of name the places that they're actually exploring.
They are. A lot of these are actually become official because they've worked with the International Astronomical Union to come up with official names for these locations.
But there's some if you look at the second table afterwards, it gives you an idea of where these places are on a picture of the actual rock itself.
Mm-hmm.
So, I see where Alice's Wonderland is.
Mm-hmm.
Why not?
Yes. Hard to that map that's all like drawn and rectangulared out, covering the entire surface. Hard to picture that as sort of a cube type of object when you see it all stretched out like that, compared to like a rounder planet. It's a little easier to figure out where you're looking at. So,
looking at this, one of the place names is Ryujin, and it's a dragon god who was Princess Otahimi's father.
Mm-hmm.
And it comes from Ushima Taro, which is a story from Japan. And there's a nice. The French actually did get a crater one of the biggest craters outside the equatorial ridge is Cornelian, which is Cinderella in French.
Okay.
So they're all listed there.
So maybe they usually pick a theme, and they kind of stick with the theme. Like Venus craters were all named after female mythological, I think female mythology, stuff like that.
Yeah.
And this one is mostly Japanese, of course. Yeah. So it's an interesting article.
As I say,
did all this, by the way.
Why not? No doubt the Osiris Rex team will want to be able to use their names on Bennu.
Mm-hmm. But it's the International Astronomical Union that is the official namers of astronomical objects. Now, names can be submitted, suggested, but they actually decide officially. Their committee does that.
Well, okay. I'm gonna.
What you gonna do?
Pluto's place names. Place names. Now, let's face it. We named a lot of places on Pluto very, very fast during the Horizons flyby.
That would be unofficially.
Unofficially, but some of them are stuck.
Yes.
Okay, there were places like Mordor, which were being used on the unofficial namings of places. And there was Balrog was suggested, Gandalf the Grey, Mengpo, the Buddhist goddess of forgetfulness and amnesia. A lot of places were given. But Pluto is always... I grew up with there being 9 planets, and Pluto was the 9th planet. So, yeah, I have a soft spot for this. And I don't have a problem with the fact the New Horizons team wanted to have the right to pick names for Pluto.
Mm-hmm. But it has to fit the theme, and it can't have it can't have some other like actual designations on Earth or something like that. I think there are definitely rules of what you cannot name features on other objects in the solar system.
I want to say that there was some Star Trek names. I know that there was very strict regulation on what the satellites of Pluto were going to be called, because it had to stay within the Greek and Roman mythologies. So that was fun. That's fine.
Now, I grew up with obviously Pluto being a planet, but I also know that history is one of my interests, and astronomical history is one of my interests. And I also know that Ceres used to be a planet also before Pluto. And then it was downgraded to asteroid status. So I have no problem not calling Pluto a planet.
Okay,
so it's happened before.
The heart-shaped place on Pluto was called Sputnik Platana. You had Hayabusa Terra. You had Burnley. You had Tartarus, Dorsa, Elliot, the Hillary Montes. These are some of the first official names that have come out of the IAU, including Tombaugh Reggio, to honor Clyde Tombaugh, who discovered Pluto in 1930 from the Lowell Observatory in Arizona. There's the Burnley craters that honors Venetla Burnley, who as an 11-year-old schoolgirl suggested the name of Pluto for Clyde's planet. Tenzing Montes and Hilary Montes, obviously the mountaineers. Al Ariza Montes, to honor the noted Arab map maker from 1100 to 1165 to 66. And of course, Selpia Fossa, the 8-legged horse of Norse mythology that carried Odin. Yes, I am keeping an eye on the time. And of course, there is a large landmass saluting the Japanese spacecraft Hayabusa that returned the first asteroid samples. And of course, Voyager Terra is there as well, along with Elliott Crater for James Elliott, the MIT researcher.
Cool.
I will get that link into chat very, very quickly, because I know we're running out of time.
Yep. All right, everybody. Try not to hear the phrase "my Corona" when you hear the song "My Sharona" and see if you can do it. I think it's time to call.
Yeah, time to call the ship. Captain Savick, this is the away team. StarStorm, Marty and myself are ready to beam up. We've had a great show. Thank you for being here, and we will see you next week.
Good
night, everyone.
We hope that you've enjoyed this program from AFM Radio, the broadcast service of Astronomy.fm. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are Astronomy.fm. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is Astronomy.fm Radio.
Hi, this is Tavi Greiner, Astronomy.fm's Vice President of Communications. If you enjoy our programming, please let us know with a donation to astronomy.fm/donate. We really do rely on your support, and it's true, every little bit counts.
AFM.
There I was, doing my thing, and all of a sudden, wham! Astronomy right between the eyes.